We are back, and we are going to talk about today the indefinite integral and the FTC, fundamental theorem of calculus. And so first, let me try to motivate what we're about to do here. So last time, we talked about this fundamental theorem of calculus, which told us how to compute things like the integral from 0 to 2 of, let's say, 2x dx. The idea the fundamental theorem of calculus says basically try to find a function whose derivative is 2x, and then we can use that function to evaluate this definite integral. So the idea is, okay, here, obviously, the function you could use is x squared because its derivative is 2x, and then we're going to go evaluate this from 0 to 2. And so then this is equal to, you plug in a 2 and you get 2 squared, minus, then you plug in the lower limit, 0 squared, and you get back 4. And so the answer should be 4. Now, this was relatively simple to do because we knew the antiderivative of 2x. We knew the function x squared whose derivative is 2x. So x squared, the derivative is 2x, whereas the antiderivative of 2x is x squared. So these are, new words probably to you, but the antiderivative goes that way, and of course the derivative we can go back this way. So the idea is if you can find the antiderivative of this integrand, then you can evaluate this definite integral. But it could be a little bit harder than you think. So how would we do something like x squared minus 7x minus 2 dx? And suppose, again, we're going from 0 to 2. How would we find this definite integral? Or worse yet, what if we had the definite integral from, let's say, 1, well, let's not do 1, let's do 2 to 3 of 1 over x ln of x dx. How would we evaluate that definite integral? So what are these two definite integrals equal to? So we want to try to figure out a way to do this, and what makes this problem difficult is the fact that the antiderivative of x squared minus 7x minus 2 is not real obvious at first. And the same thing here, the antiderivative of 1 divided by x over ln of x is not real obvious. So what we're going to do is we're going to look at a different object called the indefinite integral. So we have these two objects, the definite integral and the indefinite integral. And so what is the indefinite integral? It looks kind of like the definite integral. You just don't have limits of integration here. So you have like the integral of just f of x dx. And so now let me write down how we say this. So this is just said the integral, and this is the indefinite integral. So the indefinite integral. And this is said then the integral of f of x dx. And hopefully it's obvious to you how these things sort of line up. Here's the integral sign right here. So here's the integral. So that's the integral part. And then you have your f of x right here. So here's f of x right there. And finally, you have dx right there. And now when I see these symbols, it's, I know it's not the definite integral because there's no limits there, so it means a slightly different thing. What this is actually asking a question. This is equal to the antiderivative of f of x. So it's saying, hey, can you find a function such that when you take the derivative of that function, you get f of x? So we can do some really simple ones like we just did above. What's the integral of 2x dx? And what we'll say is that this is actually x squared plus c, where c is called the constant of integration. And the idea is really this. I mean, c could be just any old number. I mean, it could be 0, so you just get x squared back, and the derivative of x squared is 2x. But realize that it could also, c could be just 1, because the derivative of x squared plus 1 is also 2x. Or c could be, minus 1, so you could have x squared minus 1. And again, the derivative of x squared minus 1 is, again, 2x. So these are all good or possible solutions to this indefinite integral. It's easy to make the distinction between definite and indefinite. Definite have limits, so this is a definite integral. Whereas if you don't write the limits, then it's an indefinite integral. Oh, let's draw that better. So integral from 2x dx. So the top one this is a definite integral, whereas the bottom one's an indefinite integral. If you have limits of integration, it's definite, and you get actually a definite number out. Whereas here, you don't get out a number, you get out actually a family of functions, because plus c can be anything. So it could be 0, it could be 1, it could be negative 1, it could be a half, it could be pi, it could be any real number. All right, so we talked a little bit about the notation. And again, when you see these symbols, I no longer think area for these symbols. Now I think, oh, antiderivative. Right? So find a function whose derivative, right? So find some function here so that if you take the derivative of this function, you get back that little f of x. Okay, so now if we want to do stuff, like we want to figure out how to do these definite integrals, we're going to have to learn our different sort of techniques of integration. Now in Calculus 2, you'll learn most of the techniques. In this lecture, what we're going to do is we're going to look at these rules of integration. So just like we learned rules of differentiation, we're going to learn a couple rules here. Today we're going to learn 4 rules, how we take the integral. We're going to learn how to take the integral of constants. So if you give me the integral of, let's say, 3 dx, how do I find the antiderivative of 3? Or if you give me a power rule, so we'll do this power rule also. So if you give me x to a power, so like x squared dx, right, how do I find that integral? How do I find its antiderivative? We'll also talk about what happens when we deal with constants. So how do we find the integral of 3 times x squared dx? How are we going to do something like that? And then finally, the sum rule. So how would we find the integral of, let's say, 3 plus x squared dx? So we're going to learn these 3 rules today, and then we're going to use the fundamental theorem of calculus to evaluate some definite integrals that look kind of like this. This one right here. This one, below it, we'll have to wait a week. To do this one, I'm going to have to teach you another technique of integration, which is called substitution, and we'll do that next week. All right, so let's look at our first example. So our first example involves what's called the constant rule, and I gave you a handout with all the rules on it. So the constant rule basically says to take the derivative of a constant, so not a derivative, an integral. So take the integral of a constant, so the integral of k dx, where k is just any old constant, so some number, 2, 3, 4, a pi, a half, just some constant number. It's going to be a constant times x plus c. So that's what the constant rule says. And we have some simple examples over here. So like if I want to take the integral of 5 dx, it's going to be 5x plus c. And notice you can always check your work by taking the derivative. So the derivative of 5x plus c is 5, plus the derivative of constant is 0. So it checks out, so it works. And don't be confused by pi. Remember, pi is just another constant. So the integral of pi dx is just pi x plus c. So this first constant rule is really easy to apply. Let's step it up a bit and look at what's called the power rule for integration. So the power rule, similar to the power rule for differentiation, it says the integral of x to the n dx is equal to, and you add 1 to the power, so x to the n plus 1 divided by n plus 1 plus c. So this is the power rule. And again, you can look on the sheet, and you can use that as reference, but be careful. Right? Make sure you write down the power rule so you know how to use it. And it's really the inverse of the derivative. So remember, for the derivative, if you have x to the n and you take the derivative, the n will come down, and you'll have x to the n minus 1. So now you do the opposite. Right? Instead of having the n come down and taking n away from it, the opposite would be add 1 to the exponent and divide by it. Right? So notice this. You're multiplying and then taking away 1. The inverse operation would be add 1 and divide by it. So that's what we're doing here. And so these types of integrals become relatively easy if you remember the rule. So the integral of x to the 5th dx, you simply add 1 to the power, so I get x to the 6th, and divide by it. So divide by 6 plus c, plus my constant of integration. You can always check your work. So the 6 comes down, cancels with the 6 on the bottom. I get x to the 5th plus 0. So what's nice about the integral and different from the derivative is you can always check your work on the integral. Now on the integral of square root of x dx, before I can actually integrate this, I need to write this as a power of x. So I have x to the 1/2 dx. Now I haven't integrated this at all. I just wrote to the 1/2 power, so I wrote it in power form. And now I can integrate, so I add 1 to the power. That's what the power rule says. It says add 1 and divide by it. So I'm like a machine. You know, I just kind of say add 1 and divide by it, and then plus c. And then on the side here, I can figure out what is 1/2 plus 1. Well, that's equal to 1/2 plus 2 over 2, which equals, add the numerators, keep the denominator the same, so 3/2. And so this is equal to x to the 3/2 divided by 3/2 plus c. And then when you divide by a fraction, it's the same as multiplying by the reciprocal, so this is equal to 2/3 x to the 3/2 plus c. And the rule is this: if they gave it to me in radical form, I should put it back in radical form. So this is equal to 2/3 the square root of x cubed plus c. And remember, I can pull out an x. The square root of x cubed is really the square root of x squared times x. So this is really 2/3 x root x plus c. And that's my final answer. So I'll put that in a box because it took a while to get there. Now you can check your work, and I would probably check my work starting here. So the 3/2 comes down, cancels with the 2/3. This becomes 1/2. And so I get x to the 1/2 plus 0. And that is the square root of x. So again, you can check your work on these. All right, so now what can we do? We can integrate constants. You know, so if I give you the integral of 3 dx, you immediately say, oh, that's just the 3x plus c. Or if I give you something nice like x squared dx, and you want to integrate that, you simply add 1 to the power, so you get 3 on top, and divide by it, plus c. The next thing we want to talk about is how do we integrate when we multiply a function by a constant. So I called this the constant rule part 2, and it says the integral of a constant times a function dx is simply equal to the constant times the integral of the function dx. So in some sense, you can just leave the constant alone, or if you want, ignore it, just copy it down. So like if I want to do the integral of 5x squared, this is going to equal, I can just copy it down, 5, add 1 to the exponent, divide by it, plus c. And so I can leave it just like this, is fine. Some people might also write this as being equal to 5/3 x cubed plus c. It doesn't matter. They're equivalent ways of writing the same thing. Notice you can check your answer. The 3 comes down, cancels with 3 on the bottom. You get 5x squared plus 0. So it checks. The one below this is a little bit harder because it's written in radical form, so I have to rewrite it in power form. So this is the integral of 10, and then I have x times x to the 1/2 dx. And here I'm going to add exponents, so I really have the integral of 10 times x to the 1/2 plus 1 is 3/2. So 3/2 dx. And I have not integrated anything yet. I just rewrote everything in power form. And so now I'm going to integrate. I can just copy down the 10. Just copy down the constant. That's what it says. And then integrate x to the 3/2. So that's x to the 3/2 plus 1. And then divide by it. So 3/2 plus 1. All plus c. On the side over here, I'll figure out what 3/2 plus 1 is equal to. So that's the 3/2 plus 2 over 2, which is equal to 5 over 2. And so this is equal to 10 times x to the 5/2. And then this is divided by 5 over 2, all plus c. And so this is equal to 10 times, if you divide by a fraction, you can multiply by its reciprocal. So 10 times 2 over 5, x to the 5/2 plus c. And here you can get some cancellation with the 5's here. So you get 2 times 2, and that's equal to 4, x to the 5/2 plus c. And again, the rule is if they gave it to you in radical form, you should put it back in radical form. And so this is 4, the square root of x to the 5th plus c. And that's actually equal to, since x to the 5th is x squared times x, this is going to be 4. I can pull out an x times x, so x squared, square root of x, all plus c. I'll put a box around that one. And you can check your answer. I'd probably check my answer way back here. So if I take the derivative of this thing, the 5/2 comes down, I get 20 over 2, which is 10, x2, and then I subtract 1, so I'm going to get x to the 3/2 plus 0. And that works. That's 10 x to the 3/2. All right, the last rule we want to take a look at today is the sum rule. And for the sum rule, this rule tells us how to take the integral when we add two functions or subtract. So if you have f of x plus g of x dx, and you want to take the integral of the sum, well, it's just going to be equal to the sum of the integrals. So the integral of f of x dx plus the integral of g of x dx. And it also works for the difference. So if you take the difference here, so the integral of the difference is also the difference of the integrals. And that should be a g right there. It's kind of hard to see. All right, so let's take a look at the first example, and I'll show you how this works because it's real simple to apply. It just says if you want to integrate this difference and sum, just integrate these things individually and you're done. So to integrate 7x squared, you just copy down the 7, you write x, you add 1 and divide by it, minus, copy down the 3, you add 1, remember there's a 1 here, so I add 1 and get 2 and divide by it, plus the integral of a constant, the integral of 1 is just x, and this is all plus c. And you can leave that just as it is, and that can be your answer if you like. Again, some people might write this as being equal to what? To equal 7/3 x cubed. It's really the same thing, minus 3/2 x plus c, but they're the same answer. All right, let's look at the one below this because it's a little bit harder, and I'm going to copy it down right here so we have some more room. So I have the integral of 1 minus x squared over x dx. And that's equal to, all right, so understand what we've done so far. The only thing you can integrate constants. So the integral of a constant dx is a constant x plus c. And you can integrate powers of x. So x to the n dx is equal to x to the n plus 1, so you add 1 and divide by it, plus c. So these are the only two types of functions you can integrate. If it's not one of those two types, then you have to figure out how do I turn it into those two types. And so if you look at this, and once I show you how to do it, it becomes quite obvious. So how are we going to do this? And the trick is this. when you take, let's say, 2/5 plus 3, let's not do 3/5. Let's do 3/5. That's fine. 3/5. This is actually equal to 2 plus 3 all divided by 5. And now hopefully this gives you a hint. So look at this. And does this tell you how to integrate this thing, right? This integrand here. So how do you integrate this? Using this sort of as a clue as to what to do. And maybe you saw it, maybe you didn't. But the idea is, instead of pulling the fractions and putting them together, right? I guess instead of putting them together, you want to pull them apart. So you can pull this fraction apart and write this as 1 over x minus x squared over x. And this is then a dx. And if you do this, and oh, I guess I made a typo here actually. This was supposed to be an x, so change that to an x. That was supposed to be an x right there. All right, so now if you do this, what's going to happen is you get the integral of x over x, which is 1, minus x squared over x, which is an x, dx. And now you haven't integrated anything. You just rewrote this in a form that you can now integrate. Because you can integrate a constant, well, that's just x, minus you can integrate x, you add 1 to it. Remember, there's a 1 right here. We typically don't write, so you add 1 to get 2, divided by 2, and then plus c. And so this is my answer for that integral. All right, so the last thing we're going to do, so we know these 4 rules now and how to use them somewhat. And so we want to apply these rules to a definite integral using the fundamental theorem of calculus to evaluate it. So let's take a look at this example, and then we'll use our calculator to check to see if we got the right answer. So to do this, what I would do first is I would find the antiderivative of the integrand here. And notice how the indefinite integral sort of implies, it's implied here. Here's sort of the indefinite. Oh, you can see it here. Let me highlight it for you. So the indefinite integral is right here, the integral of this thing, dx. And so it's kind of telling me, yeah, find that antiderivative. So use those rules of integration. So you add 1. These are just power rules. So it's 5/7. You add 1. So you get x to the 6 divided by 6. Minus, I have 6. I add 1. So I get x cubed and divide by it. So divided by 3. Minus 3 over 4. Then I add 1. So it's x squared. Remember, there is a 1 here. We just don't write it. So x squared divided by 2. And then minus the integral of a constant. It's a constant times x. And then instead of writing plus c, I'll write evaluated at from 0 to 1. And in a minute, I'll show you exactly why we never write plus c, because it's sort of redundant. And then I'm going to clean this up a little bit. So this is equal to, and then I have 7 times 6, which is 42. So I have 5 divided by 42, x to the 6. And then minus 3 goes into 6 twice, so I have 2 x cubed. And then minus, then this is an 8 here, so I have 3 divided by 8 x squared minus 9x from 0 to 1. And now we're going to plug in 1. So if you plug in 1, you're going to get 5 over 42, and 1 to the 6, of course, is 1. Minus, again, plug in 1. 1 cubed is just 1. Minus 3/8, and then minus 9. And then we're going to plug in 0. So then minus. Now when you plug in 0, notice there's an x in front of or behind each of these terms, so you're just going to get back 0. And so this is going to equal 5 over 42 minus 2 minus 3 over 8 minus 9. And I'm going to cheat a little bit because I don't want to find a common denominator there and subtract those off because the numbers are a bit messy. So I'm going to use my calculator to do this. And we have to wait a minute here for it to pull up. And so here it is. Okay, so let's quit this, clear that, and get rid of that. Okay, so what I have is 5 over 42. So 5 divided by 42 minus 2, and then minus 3 over 8, and then minus 9. And so I'm going to get out this number, which of course I can convert it to a fraction by using my fraction button. And so this is equal to negative 1891, so 1,891, divided by 168. So good thing I had my calculator with me, because it would take me forever to find that answer by hand. Now I want to check my work. So to check my work, what I'm going to do, and there's several ways to do this, but I'm going to graph this thing. So I'm going to graph 5 divided by 7, x raised to the 5th. So I'm graphing the integrand here, and then minus 6 x raised to the 2, and minus 3 divided by 4 x. Oops, I keep hitting the wrong button here. So divided by 4 x, and then minus 9. And so there's the integrand. Looks good. I'll make my window go from 0 to 1, and then zoom fit it so I can see this graph. And because my answer is negative, I would expect this to fall below the x-axis. So when I find this area underneath the curve, right, so here's what I got. And I'm probably guessing that it's underneath the graph, underneath the x-axis, just like this. So 0 to 1. So I bet you when it graphs this thing, right, it's going to be this area right there. So let's see. And so I'm going to hit second trace, go down to number 7, which is the integral f of x dx, and lower limit 0, upper limit 1, hit enter, and it shades that region. And it's going to give me out this negative 11.25595. So it says that this area is negative 11.25595. And I can get off this screen here, so second quit. And I can actually, I wonder if it'll let me do this. I wonder if I hit enter, what will it give me? Well, what I can do here is I can actually write down what is negative 1891 divided by 168, and I get out exactly what I found there, negative 11.25595. So this checks, and it's a good answer, and I'll see you guys in lecture tomorrow.